Okay. Hi everyone, we are Group 8. Our team have 3 members, Mạnh Hải, Thành Long, and Mạnh Tiến. So today we will present about visualize basic data structure, such as linked list, queue, and stack. As you know, queue, stack, and linked list are very basic data structure. They are there are a lot of applications, so they use frequently in computer science to students. However, they are a little bit difficult to comprehend their definition. Based on problem statement, we decided to build a simple application to display and explain some basic operation on the structures. So now I will give you some overview about the data structure. First, I will talk about linked list. Linked list includes a list of element. Each element is what we usually call a node. Each node have data and the pointer to the next node of the linked list. Linked list were controlled by the node head and the node tail. In the node tail, the pointer points to the new value. Next, I will talk about queue. Queue structure is implemented beyond array or linked list. So queue will controlled by the node head and the node tail. When we want to insert new element in the queue, we call it enqueue. So when we want to delete an item, we will dequeue. We call it a dequeue. And so the mechanism of queue we usually call in short a first in first out. So I will talk about stack. Stack also is implemented by array or linked list. The stack were controlled by the top pointer. When you want to insert new item, you will push the item in the top, and when you want to remove item, you will pop item in the top. So the mechanism of stack were called in short is first come last out. So next I will talk about the UK diagram. UK diagram will give you information about how user interact with our application. First, user can get help from our application. From get help, you can see that some basic operation with our application support for the data structure. So besides, user also can choose type of data structure. Before start, user must choose type of data structure. So when user choose linked list, user can create linked list, insert new item, find item, remove item. In terms of stack, user can create stack, put element into stack, or pop element from stack. In terms of queue, user can create queue, dequeue, and enqueue. So before I stop, I want to introduce Mạnh Hải. He will continue our presentation.
All right. So, hi everybody. My name is Mạnh Hải, and to continue our presentation, I would like to talk about the general class diagram. All right. And as you can see, there are 4 main packages in our application: exception package, model package, controller package, and application package. All right. First, we will talk about model package. All right. Because list, stack, and queue objects have some operations in common, such as create random list, insert new element into the list, or remove element from the list. We decide to create a general class for the code to be more reusable and more organized. and it is a data struct class. All right, and then data struct class will associate with an element class. An element object is actually represented by a small circle with a number inside, and I will talk about it in more detail later on. All right, and in order to implement operations of those data structure, we use interfaces. There are three interfaces: uh, list interface, stack interface, and queue interface. And each interface will be implemented by each class corresponding. For example, a list class will implement list interface, stack class will implement stack interface, and queue class will implement queue interface also. All right, let's talk about controller package. Controller package is responsible for controlling screen. And as you can see in our application, there are five screens: list screen, stack screen, queue screen, option screen, and help screen. All right. For example, list controller will control list screen, and it will associate with list class because list object will be created as an attribute in list controller. All right. And similarly, stack controller will associate with stack class, and queue controller will associate with queue class also. All right. And this is a reception package. And there are two custom packages in our application: data structure length exception and index exception. For example, in a list screen, user have ability to create a random list, right? And in order to do so, a user must provide a length. So if a length which is inputted is invalid, for example, if a length is a string or a negative number, an application must write an exception and let an user to know. Similarly, with index exception, if an user want to remove an element from the list, they must provide an index of this element. All right. And again, if an index is invalid, all right, an application must also write an exception and let the user know. And this is application package, and again, I will talk about it in more detail later on, right? Now let's talk about detailed class diagram. Like I said before, data struct is actually a general class, uh, and its property must be inherited by list, stack, and queue objects. And because of that, its properties must be something the most common. All right. For example, element container attribute is actually a pane that contains elements. All right. And a data struct class must support three main basic operations: create random list, remove element, and insert element. All right. And in terms of an element class, like I said before, an element object is actually represented by a small circle with a number inside. So it must have a circle attribute and a text attribute. It also has two constructors: create circle method, create text method, and change background color. All right. For example, if an element is selected, its background color must be changed in order to be different with the others. All right. So we can do that by using change background color. And in terms of interfaces, with this interface, there are four operations that is going to be supported: insert, remove, find, and create. With stack interface, there are only two operations: push and pop. Similarly, with queue interface, they are in queue and dequeue operations. All right. And let's talk about an exception package. As we may see, both data struct length exception and index exception only has one constructor, and the constructor only has a string as an argument and also a message. All right, and it's pretty simple, isn't it? The main class has responsibility for holding the stage, So uh, it must navigate between screens, and we can do that by using joint screen methods. All right. So I think it's pretty much everything that I want to talk about general class diagram and detailed class diagram. To continue our presentation, I would like to introduce my friend Nguyễn Thành Long.
Hello everyone, my name is Long and I will show you about the OOP techniques we apply in our project. So firstly, I want to show you about the inheritance and abstraction. Our list class inherits from the data struct class and implements the interface called iList. And the iList interface is defined for some main features of the list that users only need to know that create, insert, remove, and find an element. Also, the list class extends the data struct class. The data struct class is the class to handle the main logic behind these features, such as create data struct and insert element to data struct, remove element from the data struct. Similarly, we have also the stack class inherit from data struct and implement interface iStack, and the queue class inherit from the data struct class and implement an interface called iQ. Next one is the association. We have the list controller class use the list object as an attribute. The list controller is the a class that control an event when user click on button. So what happens next? They just need to call a function from a class list from the list object, and no need to care about the logic behind it. Such as when, for example, when user click to create a list, new list, so the list controller will call the method list method create from the object list. Similarly, we have the stack controller use stack as an attribute, and also with the queue controller with the queue object. Next one is the polymorphism. In data struct controller, the data struct object is added as an attribute with the purpose to handle the create random list and the reset operation in list, stack, and queue, because all three screens had the create random list and the reset operation. You can see in this code we have the data struct class is used for both the linked list controller, stack controller, and queue controller. We also implement encapsulation when implement class element list queue. This class with the private attribute and the getSet method. The next is the override. The method create random list is overridden with in all list, stack, and queue, because in list, stack, and queue they are a little bit different with the when I create and random list. For example, when I create a list, I just need to care about which element is the head of the list. But with the stack and queue, I need to know both which one is head and which one is tail. So they are head a little bit different. So I have to override the method create random list. Finally, we apply overload in the element class with the true constructor. So the first one is without the coordinate, and the second one is with the coordinate for the element. So that's all about our presentation. If you have any question, please comment behind. Thank you. Below.